Welcome to the YouTube channel H2O Chemistry, your chemistry teacher Satyanarayanan. Learning is very important in every life. So choose a subject which you love so that you will not find any difficulty. You'll be very interested to learn what is there and what we can make out of it. So with this, we will start the next topic, difference between atoms and molecules. We know that atom we know many things about atom, but the atom is the fundamental particle of an element, or the element is made up of similar kind of atom. This is what we have studied. So if you divide element, finally we will get atoms. So that's what if we divide the element, we get basic unit called atoms. So can I make conclusion like this? Atom is the smallest particle of an element. Come to the next category, molecule. A molecule is the combination of atoms by a chemical bond. Yes, the atom may be a similar kind or different kind. If the two similar kind of atom bonded, we call them molecule of an element. If two different kind of atom bonded together, we call molecule of a compound. So element also we call molecules. Similarly, compounds also called as molecules. So molecule is the smallest particle of an element or a compound. I hope you understood this clearly. Next we will go to the next point. We know very well that noble gases are available in the atmosphere as a single atom, right? Single atom. That means they do not have any bond. If one helium atom present somewhere, the other helium atom will be present somewhere else. We have a huge gap between two helium atoms. That means they do not have any bond, right? Similarly, other atom, those who exist independently, do not have any bond. That's why we generally call atoms do not have a chemical bond. Come to the molecules. Yes, as I said, molecules is a combination of atoms by chemical bond. So without chemical bond, no molecule will exist. So look at this carbon dioxide. The carbon and oxygens are bind together by chemical bond. We call it as a covalent bond. Oxygen and carbon atom in the carbon dioxide molecule held together by a chemical bond. So what is the conclusion we can make? Atoms in a molecule have a chemical bond by which they held together. So they definitely have a chemical bond. But atoms does not have a chemical bond. Come to the next one. As I said already, noble gases exist as a single atom. That means they exist independently. That means as a single atom it exists. Whereas other atoms like oxygen, nitrogen, hydrogen, single oxygen atom is not available in the atmosphere because single oxygen atom is very unstable. It immediately combines with the other elements or one more oxygen. If it combines one more oxygen, it forms O2 molecule. So I can say this one single oxygen atom is very reactive. That means highly unstable. So they immediately form a molecule. So only the noble gases exist as independent atom, whereas other atom do not exist as an independent atom. So what is the conclusion we can make out of it? Except noble gases, other atoms do not exist in free state. Do not exist in free state. Free state means as a single atom. Remember. Come to the molecules. Let us take a water in a beaker. So you will find a lot of H2O molecules inside, right? So from this, isolation of one water molecule is possible. So one water molecule we can isolate. So single water molecule, similarly one carbon dioxide gas we can isolate. That means in between carbon dioxide and carbon dioxide there is no chemical bond, remember. So they present in a free state, remember, free state, right? As a single unit, water as a single unit, it's available. and between there is an attraction force, but isolation is possible. Between the two water molecules there is attraction force, but still isolation of a compound or molecule is possible. Alright, what is the conclusion we can make? All the molecules are present in the free state. Come to the last point. It's a very important one. We know very well that noble gases are inert in nature. Noble gases are inert in nature. Why? Yes, they do have a completely filled electronic configuration, whereas other atoms do not have completely filled electronic configuration. The valence shell of noble gases have either 2 electrons or 8 electrons, which is a stable electronic configuration, hence they are chemically inert. Whereas other atoms have incomplete valence shell, so in order to make the last shell complete, they react. Right? So look at this. For example, neon, it's a noble gas. The atomic number is 10, so it has 10 electrons in it. 2, 8. So 2 electron in K shell, 8 electron in the L shell. So the last shell, L shell, is completely filled with 8 electrons. So which is more stable electronic configuration, so it is chemically inert. Come to the sodium. Atomic number is 11, 2, 8, 1. The last shell is of sodium has a 1 electron. So it is not chemically inert, remember. Got it? It's highly reactive. Similarly, 17 chlorine 35.5, right? This 17 is atomic number of chlorine. 2, 8, 7 is an electronic distribution. If you look at that, 7 is the electrons count in the last shell. So it is also reactive, right? So except some noble gases, other atoms are highly reactive. Now come to the next one, molecules. Atoms have incomplete valence shell, react each other to attain stable noble gas electronic configuration. Yes, when an atom combines together, right, it forms a molecule by a chemical bond, right? Let us go and verify this with an example. Now let us see the formation of sodium chloride, Na+, right? Now look at this. Sodium has a 1 electron in the last shell, whereas chlorine has 7 electron in the last shell. Now to make it 8, it requires 1 electron, whereas it has a 1 electron excess. So which is easy process? Losing 1 is very simple, right? Here the sodium atom requires 7 electrons to fulfill this shell, or else it can lose 1 electron, so that the last shell will be 8. So which is easy process? Losing 1 is easy process. Come to the chlorine case. 17, right? It has a 7 electron in the last shell. 7 electron in the last shell. It can gain 1 electron, or it may lose the 7 electrons. But this is very easy process energetically. Gaining 1 is very easy process. That's the reason whenever the sodium and chlorine reacts, the sodium loses the electron to the chlorine, so it becomes 8. It becomes 8, so it becomes 0. So the new electronic configuration is sodium K shell, L shell, 2, 8, M shell will be empty. Now chlorine case, 2, 8, 8. Now look at this. So sodium also got 8 electron, chlorine also has got 8 electron in the last shell. So when forming sodium chloride molecule, it becomes chemically inert. So valence shell reacts each other to attain stable electronic configuration, forming a molecule. So in a molecule, atoms have completely filled electronic configuration which is stable, hence they are less reactive. So this, as per the theory, Kohl-Lewis approach, we know very well. Now molecules are, with this I can conclude, molecules are less reactive because atoms have completely filled electronic configuration inside the molecules. As a whole unit, they are become chemically inert, right? So they are less reactive. Alright, I hope you have understand these points very clearly. See you in the next video. Subscribe for more videos to understand chemistry. Thank you.